Hello everyone, I am Mohammad Rain Ali Rifat and I am from Master's second semester from Shahjalal University Science and Technology. So I will discuss about the value at risk and to expected shortfall. In the world of finance, we are often obsessed with returns, but for risk managers, the most important question isn't how much we can make, but rather how much we can lose on a bad day. So, today we are going to dive into the core framework used to answer that question: value at risk and expected shortfall. We will look at the how we measure them and from historical simulation to complex mathematical models and why the regulatory landscape has shifted so dramatically in recent years. Let's start with the industry standard value at risk or VAR. At the simplest, VAR is a threshold. It tells us that with a certain level of confidence, say 99%, our losses over a specific time horizon won't exceed a certain dollar amount. If your one day 99% VAR is $10 million, you are saying there is only 1% chance you will lose more than 10 million tomorrow. It's a powerful tool because it's reduced the complex risks of global portfolio into a single and easy to understand the number. Next, however, the VAR has a major flaw. It tells us nothing about the severity of the loss if we actually cross the 1% threshold. This is where the expected shortfall or ES comes in. If VAR is a doorway to the disaster zone, expected shortfall is a measure of what happens once you are inside. So it calculates the average loss in the tail of the distribution. So, crucially, expected shortfall is what we call a coherent risk measure because it satisfies sub-additivity, meaning it recognizes that diversifying your portfolio should technically reduce your total risk, something VAR occasionally fails to capture. So, how do we actually calculate these numbers? The most common method used by bank is historical simulation. This approach is essentially lets history speak for itself. We take our current portfolio and imagine it existed every day of the last year. So we apply those past market price changes to our current holdings, rank the results from the best to worst, and pick the loss that corresponds to our target percentile. It's transparent and doesn't require us to assume the market follows a perfect bell curve. But as we see on the such slide 5, history isn't a perfect crystal ball. White historical simulation is great at capturing fat tails, those extreme events that happen more often than statistics suggest. It suffers from the rear view mirror problem. It cannot account for regime shift or black swan event that haven't happened in the specific window of the data we are using. For those who prefer a more mathematical approach, we have to use the linear model, often called the variance and covariance method. This assumes that risk factors are normally distributed. It's incredibly fast because it uses matrix algebra to calculate risks. If you have a portfolio of 10,000 stocks, this model can give you a value at risk in seconds. However, it relies on the delta of the assets, which means it assumes a straight line relationship between the market moves and the portfolio value. But we know the world isn't linear, especially when the options and derivatives are involved. Slide 7 introduces the quadratic model or the delta gamma approach. By adding the gamma term, we account the curvature or convexity of the portfolio. This is vital for options traders as it captures the accelerating risks that occurs when markets move significantly. It's more complex and requiring a Taylor series expansion, but it's far more accurate for sophisticated books. The 2000 the 2008 financial crisis taught us that normal history isn't enough. Regulators introduced stressed VAR in vessel 2.5 instead of using the last year of data, which might have been very quiet. We are forced to pick a 12-month window of significant financial stress, like the 2008 Lehman collapse, and the calculate our value at risk based on those conditions. This prevents banks from becoming too complacent when markets are calm. Moving to the current frontier, the Fundamental Review of the Trading Book, or FRTB, has officially shifted the primary capital measure from VAR to trust expected shortfall. By focusing on a 97.5% confidence expected shortfall calibrated to a stress period, regulators are forcing banks to hold more capital against the extreme tail risks that can actually cause systematic collapse. If we look at the comparison on the slide 10, the trade-offs are very clear. VAR is easier to backtest, meaning it's easier to check if the model was right after the fact, but it ignores the depth of the crash. Expected shortfall is harder to backtest but provides a much more comprehensive view of total risk. This is why the industry is moving towards expected shortfall for capital requirements while often keeping VAR for day-to-day limit monitoring. To wrap up, remember that no single number can capture all risks. Value at risk tells you where the cliff begins. Expected shortfall tells you how far you will fall. Linear models give you speed, while the quadratic models give you the accuracy of derivatives. And finally, trust measure ensure that we are prepared for a crisis before it actually happens. Effective risk management is about using the right tool for the right portfolio. Thank you for your time, and now I am happy to take any question in the comment box on the methodology or the regulatory shift we have discussed. So if you have any question, you can put it on the comment box and I will give the answer. Thank you.